The very fast oscillation is about 200 milliseconds, where many of our daily sequences played in real time are compressed. And because they are compressed, the neuronal readers downstream, which is in the neocortex, can understand and listen because it's a powerful output. So here's a very good example that these rhythms are very useful. We also showed it as very useful because we can erase them. And if we erase them selectively, then the damage to memory is as severe as removing surgically the entire hippocampus.
So these are big principles, of course, but how do you go to a school child explaining where memory in his head or in the rat's head is? And I use the visual image of the pyramidal cells to teach school children every year in the unit in Oxford on our open day, because the pyramidal cells communicate with other pyramidal cells through little protrusions of the dendrites called dendritic spines. And these spines, during the life of the animal, a pyramidal cell, Tamás's group counted, has about 30,000 of these dendritic spines, grows or shrinks, or some disappear altogether, but the ones that are responsible for my image and memory of my mother's face are there for all my life, those spines. And there are some teeny tiny ones and there are some big ones. And the growth of the spine makes it more reliable, that site of communication, because there is more receptor, they provide a stronger signal, and also they live longer in the nerve cell's life, decades, sometimes for several decades. And with another outstanding Hungarian student who is a group leader, senior scientist in Tamás's Institute, Zoltán Nussel, we actually counted the receptors using microscopy at Oxford and discovered that the large spines have much more receptor and different kinds of receptors than the small spines, and that's where the memory stores. So you see it on the nerve cells, you see the big chunky strong connections, and you see the small connections which may be there today or tomorrow, but for it to grow it needs input just at the right time, and that's what Gyuri told is the principle, to deliver it in the right time.
But knowing about the specific receptors on these cells, on these dendrites and their spines, would that lead to generation of drugs that will either increase a normal person's or enhance a normal person's memory, or relieve Alzheimer's disease or other memory?
There is a line of research going into this direction, the so-called memory enhancers. And this is also based on the knowledge of the appearance of certain GABA-A receptor subtypes, and the localization of this is the major result of Peter's lab. These are receptors of an inhibitory transmitter called GABA, which are distributed outside the synapses on the dendritic shafts, and when they are activated by the kind of diffuse ambient levels of this inhibitory transmitter, they reduce the input resistance of the membrane, and thereby the efficacy of the excitatory synapses is going to decrease. So the idea is that perhaps by blocking these receptors could enhance the efficacy of the excitatory synapses that terminate on these neurons, or could enhance the ability to undergo synaptic potentiation, and that it should theoretically be a kind of memory enhancing process.
But it's there. There are studies in the United States, 30% of students take university students take memory enhancing drugs, and I think in Europe cannot be much behind that. So they are here in in our lives and raise very difficult ethical issues for society to grapple with. So it's happening now.
But they could become, I suppose, much more efficient.
Well, we understand a little bit. It's much easier to break a system than to improve its performance. So one way we can break a system and ask what is the underlying cause, and by that we perhaps understand and develop new drugs. One thing I understood from Tamás is that certain receptors, such as cannabis receptors, are very important, and we used in experiment a recreational dose of cannabis, or the equivalent drug, and we showed that it has a tremendous effect on synchrony, a tremendous effect on oscillations. And in fact, we could correlate very nicely the breakdown of the synchrony, and we could determine exactly how it happens. It happened mostly in the hippocampus, and the memory performance. So now, what did we learn? Well, we learned something that this togetherness, this perfect timing, channeling the information in the right direction is absolutely critical. If we just break down the timing in the 10 millisecond range, it's a disaster. How is it? Just to give you a good example, or an imaginary example, if you are listening to a orchestra, there is a conductor. The conductor is theta because it's very slow. But there are much finer interactions among the local musicians. So what you could do as a marijuana type of experiment is just exchange the position of the musicians, or put wax into their ears so they can't listen to each other. That would be a disaster. This is exactly what happens after marijuana use in my brain. So if the timing is affected, such as in schizophrenia, and there is a large school out there who already subscribes to this notion that gamma oscillations are affected, we already know where to look for those mechanisms. We know the neural substrate through the hard work of these individuals sitting next to me. Then indeed there is a good way to know where to target to this particular rhythm.
Now, the last couple of questions about the prize and the interaction with Danish neuroscience. Do you already see groups in Denmark that you would like to interact with, and what do you expect to get out of this interaction?
I had a big impact on my scientific life by a Danish neuroscientist who worked in the United States, in Charlottesville, but he was an absolute pioneering neuroanatomist and a conceptual neuronal system organizer. So he saw how the brain is organized into modules. His name was Lennart Heimer. And he and my mentor in Oxford, David Smith, were friends. So Lennart Heimer frequently visited us, and he was a great supporter. So I learned a lot from him, and both Tamás and I worked on the system that Heimer is the pioneer, the so-called basal ganglia that is diseased in Parkinson's disease or Huntington's chorea. So I already had an interaction with Danish neuroscience. Now the prize only happened very recently, so I haven't communicated with scientists yet, but I know the program for the next year, and I will take every opportunity to both learn from Danish neuroscientists and contribute as much as I can.
I can only join Peter in confirming that I will be delighted to go, and I look forward to this interaction. First at the Danish neuroscience meetings, where we will deliver lectures, and then walking around in the posters, I hope to meet young talented neuroscientists who might be interested in joining my laboratory for a longer or shorter time. I also learned from Danish neuroscience, particularly quantitative electron microscopy, stereology, which is done there at a very high standard, for example, in Mark West's laboratory. I even invited him to several summer schools which I organize in Hungary to teach morphometry and stereology to the students.
beside anatomy, there is a very strong school in Denmark. This is about brain energy. They are very good at both in Copenhagen and in Aarhus, and I interacted with them quite a number of times. But most of the time, my life has been, when it was impacted one way or another in a bigger way, it's usually not by neuroscientists. It's usually from outside the neuroscience. And one person who had a tremendous influence on my thinking is Per Bak. Per Bak is my ultimate dreamer, as well as somebody who formulates a question, and that question is translated into and generalizes it. And he generalized his self-organized criticality to such an extent that it impacted the entire world. And of course, I was the first one, I proudly say, who imported him into neuroscience.
Now, last question. What are your thoughts on what this prize can mean for neuroscience as a field?
I think once mathematicians have their own so-called Nobel Prize, the Albert Prize, I think that has done a lot of advertisement for mathematics, and I'm pretty sure that the Brain Prize is going to have a very positive influence on the field of brain research. And I hope it will also affect the way of thinking of policymakers, stakeholders who determine priorities in research at the European Union level and also at the level of the individual member countries, and draw attention to why neuroscience is so important in the information society, how these various disorders that are very rapidly spreading these days, anxiety, depression, and also due to the aging population, Alzheimer's disease, without more research into the basic mechanisms, there will be lots of societal and also health economical problems affecting these civilized societies of Europe. And I think this award will definitely attract also more talented young scientists to the field of neuroscience.
For me, this will be an opportunity to emphasize that understanding ourselves, understanding how we create knowledge, how we create cooperation or conflict in society, how we handle challenges from which there is no escape unless we address them, will be one way that the Brain Prize emphasizes that it's our brain and the knowledge of ourselves that is the only thing that can save us from ourselves.
The Brain Prize is an indication that neuroscience has come of age. When I started in my field, I worked in the Department of Physiology. There was no neuroscience department anywhere. And every single time I had to talk about my profession, it took about a half an hour introduction of what I was doing. Today, I can say I'm a neuroscientist and a high school student understands it. And they think it's cool. This is a cool science to do. This is probably the most exciting science to be done today. There are many prizes in our field. Most of them are dedicated to specific areas. The Brain Prize was just the best coined term because it captures the essence of a large field. It will generate a lot of attention. It indicates that there is a new field that is already acknowledged, and it's absolutely fantastic that it came out from a Scandinavian country for very good reasons.
Thank you very much, all of you.